Hello everyone, welcome to this 15th video on Python. In this video, we'll discuss plotting charts using Seaborn. I'll be sharing this Jupyter notebook by GitHub and I'll provide the link in the first comment. So you can access the data set from this link. It is available on Kaggle and the library tutorial is also available on this link. Okay, you can go through that. So let's start. So we'll import the important libraries here: Pandas, Seaborn, and Matplotlib. Matplotlib is another library which is widely used for plotting in Python. We'll discuss about that later. So after that, we'll load the dataset. It is again the brain stroke dataset, which we have seen earlier in the previous video as well. And after loading any dataset, we first take a look at the shape of the data frame. So it has 4981 rows and 11 columns. And you can take a look at the few rows, first 10 rows here. And we have age, age, gender, hypertension 10 kind of flag, heart disease 10 kind of flag, ever married, work type, residence type, average glucose level, BMI, smoking status, and stroke. So these are the columns that we have in the data frame. And if we take a look at the data types, we can observe that most of them are either object or float or integer. Okay, and we can observe it here as well. And then we can also take a look at if there are any NA values in the data. So if we do df.isNA.sum, we'll get that number. If there is any NA value for each of these columns, here is the output. There is no NA values. Now let's start with creating a scatter plot. So how should we do that? So the arguments here are x. What do you want to put on x-axis, y-axis, and then the data argument. You will mention the data frame that you are using. Hue argument, it is used for color. Style, it is used for markers style. So what kind of marker do you want in the scatter plot? And the legend argument is used to control the legend position. So these are the important arguments for creating a scatter plot. So here you can see that to start with, you will start with sns.scatterplot, and then you will mention x to some variable. So here I am saying x as age, y as average glucose level, data is data frame which we have loaded earlier, and the color is magenta. So you see this is how this scatter plot looks like. So we have age on the x-axis, average glucose level on the y-axis, and this is how this scatter plot looks like. So most of the data set is concentrated here where the average glucose level is less than 150, and then there are good number of records here as well where average glucose level is higher in the age from maybe around 50 to 80 years of age. Okay, so now we can actually use some other arguments to get some more information in this scatter plot. And so we'll be using hue, style, and legend adjustment arguments here. So if I mention hue to be gender, then we'll have two different colors, one for male and one for female. So you see the legend is here. Male we have brownish kind of color, and for female we have greenish kind of color. Okay. And when I mention style to be work type, then different kind of markers appear for different work types. So private job employees, it's circle. For self-employed, it's cross. Then government job, you have a square, and children, it's very less, and it's again a plus sign. So it's like that. Okay. So for example, here if you see, so this is a male private job employee, which we can observe. Similarly, you can see that in this region, many of these are green. So there are a lot of female records present in this region. So with the help of these two arguments, actually, we can get more information out of this scatter plot. Let's see how we can create a bar plot. So for bar plot, again, we have similar kind of arguments. X, which categorical value you want to put here, y, which numerical value you want to actually summarize here, data frame that needs to be used, color is the argument to specify the color, and who is the argument to actually break that chart into different categories based on a particular variable. Okay, so again, the syntax is quite similar. SNS dot bar plot, x equal to work type, y is BMI, data frame, color is sky blue. So we get this as an output. And here all these values that we see on the bar is actually the average. So it's average of BMI for private, for self-employed, for government job, and for children. And we can specify the color of our choice by changing this color argument. And if you want a horizontal bar plot, we just need to add an additional argument here, orient equal to edge. So the moment we do that, it becomes a horizontal bar plot again. We have this mean values by default as the length or height of the bars. Now, what if you want to actually add, use this maybe who argument here, and so for that, if we add who equal to gender, then this these bars actually break into two, one for male and one for female. Okay, so you can see that for private, for male actually it's around 30, the BMI, average BMI. For female it's slightly less, and it is there for self-employed as well and government job, that the average BMI for females are slightly less than male, but in children it's a little bit higher. Now we can easily create this plot, but how we can add label, title, etc. to the plot? To do that, so we'll first create the plot using sns.barplot here. So we are creating the bar plots here. So X is gender, Y is hypertension, data is DF, and who is smoking status. So we want to actually break down these bars into different smoking status as well. After that, we have already loaded this matplotlib library. So using that, actually we can add a legend. So plot.legend, we can adjust the legend. Where do we want to actually keep that? It's upper right, you can see here. And you can add X label, you can add title as well. And this all we'll be doing with the help of that matplotlib library, which we loaded as PLT at the top. So here we can observe in this chart that for different smoking status in male, how does the what is the percentage of hypertension people there? So you can see formally stroke is less than 15%, never smoked it's close to 13%, and smokes is also around 15%. So never smokes cases, the percentage of people in that category with hypertension is relatively less. And here we can see that in female actually it's less for smokes. So again, these results need further investigation, but yeah, this is how we can read this charts. Okay, now let's look at another chart. So here it is heart disease percentage in patients with hypertension by gender. So again, in this chart, we have added gender to on the x-axis. Y is heart disease. Again, it's 0 1 column, and by default, you are getting mean. Okay, so average or the percentage of heart disease patient in that category that we'll get here. Data frame is DF, and who is hypertension. So this in male with hypertension cases, we can observe the percentage of heart disease people is very high. It's around 16%. But without hypertension, the percentage of heart disease patient is very less. It's around 7%. In female also, that is the trend. So we can actually observe that maybe hypertension is very much related to presence or absence of heart disease. Okay, and again here X label and title and legend, these are arguments are actually used to modify your plot. Okay, now by default we have observed that when we actually just use the data frame with the right set of columns and create any bar plot, it gives us the mean value in those plots. What if you want something else? What if we want to have count or max or mean, any other value to be present in the bar plot? If you want to do that, then we will have to first summarize the data in the required format and then use it in our plot. So for example, here we'll first summarize the data frame, raw data frame. We'll group by work type and gender and pick this column, average glucose level, and take the sum of the average glucose level. Then we are sorting the values by average glucose level in descending order. So this is the summarized data frame. We have actually used something similar in the previous video as well, where we are plotting charts using pandas. So there also we group the data frame and then summarize it, then use the plot function to actually get the bar chart. And after doing that, we can use this summarized data frame, okay, to plot. So here we have mentioned X as work type, Y as average glucose level, and who has gender, and the data frame is the summarized data frame. Okay, so and we have also added a title here, sum of average glucose level by work type and gender. So maybe this sum of average glucose level may not be a relevant metrics to plot on this chart, but this is just an example. And here you can see that for private work type employees, in female, this is higher than as compared to male. So like that. Okay. You can actually get the count as well. So in this example, you see we have count. So again, we have some summarized by grouping on work type and gender, taking average glucose level. We have just got the count, and then we have sorted it in descending order. Now again, we put work type on x-axis, average glucose level on y-axis. Data frame is the summarized data frame, and this who is gender. So if you do that, we can see that in private group, female employees are more as compared to male. Okay. Now again, this we need to actually change these y-axis level as well. Okay, because it's not the average glucose level right now. It's the count. Okay, so if you pick a particular column and do the count, the column names changes like that when you are summarizing the data. So maybe while building the chart, it is fine, but in the final chart, you need to modify it to the right column name. So it's actually count. So you should have the y-axis level as count. Should modify it to count. Okay. So let's look at another chart type, which is box plot. So again, the few important arguments are X, which categorical values you want to put on, Y is the numeric value you want to look at the chart, and kind, either it is box or swarm or something else, and the data frame which you are using. So you'll do sns.catplot with X as hypertension. So we want to create box plot on average glucose level, and we want to have in fact two box plot, one for hypertension equal to 0 and one for hypertension equal to 1. Okay, that is why we put this on the x-axis. Kind box and data is df. So we are directly using the raw data frame, and we add a title, distribution of average glucose level by hypertension. So from here we can also observe that in cases where hypertension is zero, the average glucose level distribution is like this. And you can see that the median value is very less than 100. Okay. And the 25th percentile is again far less than 100. Even the 75th percentile values is also close to 110, 20, something like that. But in cases where hypertension is 1, the median is still higher than this median where hypertension is 0. The 25th percentile is relatively, it's kind of same, it's not exactly same, but very much close. But the 75th percentile value is very high. So with records with hypertension, actually the average glucose level is also on the higher side, it's close to 200. So this is what we can observe from this data. Okay. And if you want to create box plot with facets, so facets is like, again, splitting this box plot into few other subplots based on what kind of argument you put in column and row. Okay, so here we have two additional arguments, column and rows. In column I have added stroke, and in row I have added gender. So this is how the plots look like. So this is gender male, row is gender. So this whole row is gender male only, and this whole row is gender female. And column is stroke. So stroke equal to 0 is in this first column, and stroke equal to 1 is in the second column. So we can actually break the chart, this box plot, into different categories and observe it. Now this particular set is for gender male only, where stroke is 0, and it is further divided into hypertension 0 and 1. And here gender is male only, stroke equal to 1, further divided into hypertension 0 and 1. So again, from here we can observe that for even for male with stroke equal to 0 and stroke equal to 1, hypertension 0 case only, also if there is a stroke, this average glucose level is on the higher side. If there is a stroke, even for in hypertension cases, the average glucose level is on the higher side. But in female, if you see, even if there is a stroke, for hypertension cases, it's actually a bit less. Maybe it may be because of less number of records. That also we need to further investigate. But again, there is not much of a difference what we can observe. But there is a very high difference observed in case of male records. There is another important kind of chart that we should know how we can create it using Seaborn library, that is histogram. So the syntax would be like this. If you use sns.histplot, you will mention data, variable and bins. If you use sns.displot, you will mention again data, variable, but you also need to mention kind equal to hist and bins equal to n. Who is again variable for column. So which variable you want to actually split the plot into. And then bin width also, either of these two will be using either number of bins or the bin width. So if you, for example, here for average glucose level, you want to split the overall data set into 50 buckets, then you will mention bins equal to 50. But if you want to specify the range that you want to split it into bucket of size 10 or 20, like that, then you will mention the bin width. Okay. So in this first example, if you see, we are just plotting average glucose level, and we have specified bins equal to 20. So whatever be the range of the data set, we are just bucketing him into 20 buckets only. So these 20 bins are plotted here. But if you specify the bin width argument here, so for example, if I just want to mention that I want to see this histogram in maybe steps of 10, something like that. So with this bin width 10, It's still running. Yeah. So it's like this. So you have this 50 to 60, 70, 80, 90, 100. So it's this is in the steps of 10. So the width of each of this bucket is 10 only. Now if you look at the histogram here, again it is created but using a different function, this plot, and here I have to mention kind equal to hist, and we have 20 bins. So overall these number of these bins are 20 here, and it's a bit kind of same only. Actually it seems like here also the bin width is very much close to 10 only. Now if you want to observe two histogram for different categories on the same plot, then you can use this argument who, and here I have mentioned who equal to stroke. So we are getting two overlapping histogram, and for actually for proper visibility you need to mention alpha as well, which actually changes the transparency level. So with low values you can observe these two different charts, plots on the same chart. So we can observe that for stroke 1, these number of records are very less in all these buckets, while most of the cases are actually where there is no stroke. But yeah, the distribution, the pattern is kind of same. So wherever you see a peak in stroke 0, around the same bucket actually you have some kind of peak in stroke equal to 1 as well. Okay, so that is what we can observe from this particular histogram, where we are using this O argument at the same time. Now let's look at the density plot. So to create a density plot, we'll use this sns.kde plot function, where you just need to mention the variable and the data frame that you are using. And if you are using dist plot function, then you have to mention kind equal to kd. So here we can just look at the density, and we can observe that around glucose level of 100 there is a peak. So more number of people are having this average glucose level of 100, and the density there is also high both for male and female, and there is another peak at around 220 or 230, like that. The same plot is actually created using dist plot function and with almost similar kind of arguments, and we are looking at the same chart here. You can also create a few different kind of plots as well in using the Seaborn library. So one of them is joint plot. So here you get the scatter plot as well as the distribution of the variable on x and y axis all together. So the syntax is like sns.joinplot. Data is the data frame that you are using. On x-axis we want average glucose level, on y-axis we have age. So this is how it is distributed. This is how the scatter plots look like. We have observed a variant of this at the top, where age was on the x-axis and average glucose level was on the y-axis. And we can also observe the distribution. So looking at the age distribution, we can see that there is a good number of people around age bucket around 80, and then we have a peak around 40 as well. And if you look at the glucose level, for majority of a good number of records actually, uh, the glucose level is less than 100 only, and with a peak around maybe 70 80, the bucket around 70 80. So another plot that you can actually create, and which is very useful when you want to quickly observe the variables in your data set, is pair plot. So the argument is very simple. All the columns will be used here, and you just need to mention pair plot data equal to data frame. So whatever columns here are present here, age, hypertension, heart disease, average glucose level, BMI, stroke, all the numeric columns. In fact, it will create a distribution for that individual column. So for age, we have this distribution. For hypertension, we have the distribution, and the distribution is on the diagonal axis. For heart disease, we have like this. We just only have two values, 0 and 1, so it's like this. For average glucose level, it is like this. For BMI, it is like this. For stroke, it is like this. And in all other charts, you have this scatter plot. So this is age and hypertension. For these two variables, this is how the scatter plot looks like. And again, this is hypertension and age. So it's kind of mirror image. So these two charts are image of each other like that. So similarly, so we have different scatter plots. Age versus other variables scatter plots are here, and the distribution of age is here. So with this, just one line of actually code, you can get some good understanding of the numeric variables which are present in your data set, their relationship with other variables as well as their own distribution. You can easily understand. So this is again a very useful plot. So I hope you will find this video to be informative. So do like the video, subscribe my channel, share it amongst your friends. See you in the next video.